Okay, so this lesson we're looking at the mid-ordinate rule and the trapezoid rule. Basically, we're looking at measuring regions of land that are irregular, so they have curved boundaries. And so you can see in the diagram here, we often have things like rivers, etc., bounded by roads that give us some straight sides and some curvy sides. Now, one of the most important uses of surveying techniques is to accurately establish property boundaries so that the ownership of property can be registered. So it's really important that in construction, landscaping, property development, land subdivision, mining, navigation, mineral exploration, that they can actually use these techniques correctly. So first of all, we're going to look at the mid-ordinate rule. Now, the mid-ordinate rule is basically looking at using rectangles as a base. If there is at least one straight boundary within this irregular shape, and often you can do that yourself by drawing a line, a survey line, directly down the middle and then doing offsets from that survey line. That gives you a straight boundary, and you would just do the area of one side and then you would do the area of the other. So you just need one straight boundary and mid-ordinate lengths. Okay, now these are the offsets from the perpendicular, so that's these lines here. Now technically, because of the curve at the end, the more you have, the less error. The more offsets or more mid-ordinate lengths, the less error at the end here you have for area. So in the field, a surveyor establishes the survey line and measures it. So in this one, it would be along here. But as I said, you could do it down the centre of the shape and then find the error on either side. So you need to establish a survey line. Then that length is divided by 10, and the first offset is taken at half the distance from A. The remaining offsets are taken at distances equal to 1/10 of AB. Okay, so you're basically dividing this line into 10 so that you can have 10 different offsets. In this way, the offsets that are taken are actually the mid-ordinates and can be used directly to calculate the area of the region. Now, it doesn't always have to be 10. In fact, the more you have, the more accurate your result will be. The mid-ordinate rule, sorry, actually need the pen, don't I? Mid-ordinate rule is okay, I'm having a slight trouble technically. Mid-ordinate rule. Area of region is approximately equal to, now I'm not going to have enough room to fit this in, so I'm going to write it out. You would do it all on one line. So length of survey line multiplied by the average of mid-ordinate lengths. Now you could shorten this a little by basically you could write area of region, with it being in the like a subscript. Area of region is approximately equal to L, which is the length of the survey line in subscript, multiplied by the average, which is X bar, of the mid-ordinate lengths. So this is the rule that I would use. Okay, so this is just the basically the rules. We've got our mid-ordinate rule down here. And remembering down here that the more offsets, that's supposed to be more. Let's just fix that. So more offsets, more accurate. Okay, so to find the area of the region, we have to complete 2 steps. So step 1 is to find the average length of the mid-ordinates, because that's part of the rule. We need to actually know the average lengths. So to do that, I'm going to find the average, and so that will be the sum of the mid-ordinates the mid-ordinate lengths divided by the number of lengths. So in this instance, we're going to do 15 and 12 and 22, 28, oh, that's an add, and 27 and 29 and 24, 26, oh, I'm going to run out of room, and 29 and 14. Okay, terrible that. Divided by, there are 10. So if I actually count them over here, you know, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 15, 12, 22, they're all my mid-ordinate lengths there. You can see here, this is my survey line, and they've gone, if we start here at 0, even if that's 412, all the way here to is 80. Okay, so I know my survey line is 80, and they've been split. So if I just calculate that, I end up with 22.6 metres. Now let's have a look at our criteria. So far we've got our K1M1 here. And technically I should have put find the average of the mid-ordinates. And then that would have been an M1 as well. And then down here we have our K2, and then this is our K3. Okay, so my next step, step 2, is to then find the area of the region. So again, I'm just going to state my purpose. I'm just going to move this up so that we have enough room. Need quite a bit there. Okay. And so to find the region, I just use my rule now. So area of region is approximately equal to, because again, it doesn't give us an exact area, but it gives us a pretty good indication. The length of the survey line multiplied by the average of the mid-ordinate lengths. And so basically we sub in. So the length of the survey line we established before up here, so it went from 0 to 80. I can't see that anymore, but it goes to 80. So it is 80. And our average was 22.6. And so that gives us 1,808. And of course it's area, so I'm going to make sure I do meters squared. Therefore, the area of the region is about 1,808 square meters. And so if we look at our criteria there, we've got M1 here for writing our strategy, the steps in our strategy. This is M1K1, showing our rule, again, the strategy we're using to solve. K2 for our subbing in, and K3 for our calculating. Down here we have M3, our concluding sentence. Okay, remembering that it needs to relate back to the question. So the question was to find the area of the region. We have done so. So you should pause now and try some of the mid-ordinate questions in the PowerPoint. And then you can come back and learn about the trapezoidal rule. Okay, so now we're going to have a look at the trapezoidal rule. So again, we can have a look at an irregular shape, and we can approximate it by the area by dividing the shape into strips of equal width. Now, if we have a look at these strips, we can see that pretty much most of them, except this one here with the little curved bit, but basically this is almost a trapezoidal shape. See, even here, we've got two parallel lines, A and B, and then we have our sloping sides. Sloping at different angles, but we have sloping sides. Now, because of that, the rule for the trapezoidal rule actually comes from the rule for the area of a trapezium. So the area of a trapezium is half A plus B, and that's our two parallel lines every time, times height. And that's always perpendicular height. So you can see here, if this is a trapezoid, then these lengths that go across the irregular shape are our parallel lines. They're our A and B. And this width, that's our perpendicular height. So perpendicular height is always from one parallel side to the other in a trapezium. And then these are our little sloping sides. And of course we do a half because with a trapezium, let's actually draw one. With a trapezium, if we drew one like this, and then if we drew a second one of equal size over this way, do you see what we get? We get a parallelogram. So this here is a parallelogram. And again, we've got side A and B, and this is side A, and this is side B, if we use A for little and B for big. So for the same trapezium, we can add, you can see here that if we add A and B, and we add A and B, which is what we're doing here, adding A and B, and then if we multiply by the height, because basically the area of a trapezium, of a parallelogram is base times height. Now the base is going to be A plus B, isn't it? The length from here to here. And no matter which side we do, that's A plus B. So base is A plus B, and height is this perpendicular height. Well, we have the height up here too. We're still doing, this is the length times height, or the base of the parallelogram times height. And so then if we multiply by height, we get the area. And the reason we half it for a trapezium is, as you can see, it's 2 to make a parallelogram. So like a triangle and a rectangle, we have that same idea. So that's where the formula comes from, and that's why it works up here, because all of these shapes are basically trapeziums. There's slightly curved sides, but trapeziums. Okay, so let's look at the rule. So if I just move this up a little. So from that, we can deduce that the trapezoidal rule, the area is approximately, because just like before, it's a regular shape, so we're approximating, it will be the width multiplied by, I'm going to put square brackets in here, we have to find the sum of the end lengths plus 2. Then we need to multiply it by the sum of the middle lengths. And then, okay, so all of that. Now the reason we put all these brackets in is we have to find the sum of the end lengths plus 2. Then we have to find the sum of the middle lengths. Then we have to multiply those two together. That's why we've put them in square brackets. Then we take that answer and we multiply it by the width. So effectively, this part is giving us our A and B, or our length, and then our width. But across the number of them that there are. Now, just like the other rule, we do need to divide by 2, okay, or do a half, but it's easier just divide it all by 2. Okay, so, oh, actually, sorry, my bad. I technically should have put, it won't let me undo. I technically should have put that as the bracket. That's not. Okay, so we find the sum of the end lengths, then we find the sum of the middle lengths. So sum of the end lengths, add them all up, sum of the middle lengths. And then we're going to add to multiply. Okay, so let's do an example. That'll make things a bit easier. Okay, so we're going to find the area of this region. All of the measurements are in meters. So the first thing I'm going to do is write my rule. So area is approximately equal to width times square bracket, sum of end lengths plus 2 times the sum of the middle lengths. And close and bracket and put it all over 2. Okay, now it seems really long, but we're just going to step by step sub in. So easy as. So it's approximately equal to. Now the width. So the W stands for width. So we go up and we say, what's the width? Well, this is going 0, 5, 10, 15, 20. So each of these is 5 wide. So width is 5. Then I'm going to look at my end lengths. So that is going to be 15. So sum of just means add them all together, and 0. So if I have a look up here, this is my end and it's labelled at 15, and this is my other end and it's 0. There's no end, 0. Plus 2 multiplied by the sum of the middle lengths. Now if I look at all my middle lengths, I'm going to start, so 15 was the end, so 15 was the end here, so 16, all of these I've got to add in. So 15, sorry, 60, let's fix that. We've already got 15, it's an end. So 16 and 13 and 9 and 8 and 11 and 11 and 6. Okay, close our square bracket and then put it all over 2. Next, I'm going to calculate basically my brackets. So I'm still going to have 5 times, and then I'll take the square brackets away and just go back to my normal brackets because I'm going to get rid of the ones inside. So 15 and 0 is 15. So I'll work out, remember BIMDAS, brackets first. So 15, Then I still write plus 2 and times because that's outside the brackets and I'm not doing anything with it yet. And then, so see, just here outside the brackets, and then I'm going to do all of this, add all these numbers in this bracket together, and when I do, I get 74 over 2. Now again, BIMDAS is where you will get thrown if you don't do this properly. So next, I'm going to actually do that sum. So what I want to do is actually do 2 lots of 74. So BIMDAS says brackets, but within the brackets, I've got an addition and a multiplication. And BIMDAS says I always do multiplication division before I do addition and subtraction. So I do 2 lots of 74, and then I add on 15, and then I multiply that by 5. So I go 2 times 74 equals, plus 15 equals, times 5 equals, divided by 2. And when I do that, just in case your calculator doesn't do it for you, when I do that, I get the answer of 407.5. Now, I'm going to round that and say 410 square meters. Therefore, the area of the region is approximately 410 square meters. And I did forget I need to put 0 decimal places. Okay, so let's just check our criteria here. So this is my K1N1, so I've got a rule. I'm showing the strategy I'm using, so I can now get that one. K2, where I've subbed in, and again down here I'm still calculating, so that's K2. Down here I've actually done K3, that is my calculated answer. And down here where I've actually rounded, that's C1, meters squared, C1, and then actually indicating that I've rounded to 0 decimal points, that's C1. Over here is M3, that's my concluding sentence. So I've got to make sure I've done all of those things. Now, the most important thing to remember with this rule is BIMDAS. You need to just sub everything in and then slowly apply BIMDAS, do your brackets, multiplication before addition, especially within a bracket, and really you can't go wrong. Okay, so what I need you to do now is to go and complete the worksheet area of irregular shapes. There's a number of questions there for you. Yeah, good luck.